Valine is one of the 20 amino acids that's used to make a protein within the human body. Just like every other amino acid, valine has a center carbon, chiral carbon, stereocenter carbon, alpha carbon, the carbon that has 4 different attachments to it. First off, we've got a carboxylic acid where we've got a carbon with 2 oxygens. One of those oxygens is bound to a hydrogen. We've also got an amino group where we've got a nitrogen with 3 hydrogens attached to it. This nitrogen should only have 3 total attachments, so because it has an extra hydrogen attached to it, this is going to carry a +1 charge. Then every amino acid is going to have a hydrogen directly attached to the center carbon or the chiral carbon, and the thing that makes every amino acid unique is the R group that's attached to the chiral carbon. Now, at the lowest pH, the environment is going to have a whole lot of extra hydrogen. So the molecule, everywhere you can have a hydrogen, this molecule is going to have a hydrogen, or it's going to be in its fully protonated form. As you increase the pH or the environment starts to lose hydrogens and this molecule starts to have more hydrogens than the environment does, this molecule is going to have to start giving up some of its hydrogens to the environment to balance things out. The first hydrogen that's lost from the valine molecule is going to come from this carboxylic acid, and that oxygen is going to gain back its lone pair of electrons. This is going to happen at a pH of about 2.4. So at this point, this oxygen is going to now have a -1 charge because it actually has this lone pair of electrons. This nitrogen is still going to carry a +1 charge. So because you've got the -1 and +1, those balance out to 0. But this is not considered just a neutral molecule. There's actual formal charges on the molecule. So this is considered a zwitterion. Then as you keep going up in pH or the environment loses more and more hydrogen, the other place that hydrogen is going to have to be lost from is this nitrogen. And that's going to happen at a pH of about 9.7. So at that point, the nitrogen is going to gain back its lone pair of electrons as well. So now this is going to be a 0 charge neutral. This is going to be a -1 charge. So overall, this molecule is going to have a -1 charge, and that's going to happen at a pH of above 9.7. But at physiologic pH or pH of about 7.4, what this is going to look like in the human body, this nitrogen is still going to have its hydrogen attached to it. So the zwitterionic form, or the form where it's overall charge of 0, but there are places where it's a negative and positive, this is the form that's going to predominate in the human body. Now let's talk about its R group. Now, as you can see, all you see is black and white, and black is carbon, white is hydrogen. Those molecules both have similar electronegativities. All of this is going to be nonpolar. This is a completely nonpolar R group. Because it's nonpolar, that also means it's hydrophobic. This is not going to be able to have any polarity, no polar bonds, no places where it can do hydrogen bonding with any other molecule. This is the part of the R group that connects back to the rest of the amino acid. So you can see there's 2 branches in which these carbons go. So this is considered a branched chain amino acid. This is not just in one single chain. There are multiple chains and multiple branches off of this carbon of the R group. So valine is another branched chain amino acid. As with all of the other branched chain amino acids, valine is not able to be made within the human body. You have to eat it in order for it to show up in a protein. So valine is an essential amino acid. And if you have any problems with breaking down branched chains like valine has, then you're going to have a problem with being able to use and recycle valine. Valine can be broken down into succinyl-CoA, which can go back into making ketone bodies to make fatty acids. So you can control, if you eat too much valine, you can control how much valine actually ends up in proteins and doesn't cause a bunch of issues by breaking it down into other things. But if one of those enzymes that's used to break down valine into something else isn't functioning, you're going to have an accumulation of valine. And at that point, you have to end up having some kind of a low valine diet in order to not have issues because of a lack of breaking down valine.